Richardson, and I'm going to be covering today for Daily Space. Um, so I didn't really have anything planned, of course. So what I'm going to be doing is kind of somewhat picking up where I left off yesterday. Um, so talking about yesterday's stream for Astro 101, it was a special edition of me doing my research. And so I'm going to be doing that as well for today. So, what we were doing was trying to determine, well, I have a set of images. These images are of the lunar surface. And my objective is being able to attach to these images the coordinates of the corner points of the images. Of course, the images themselves have, pixel coordinates, but I want to be able to match those pixel coordinates with the latitude and longitude. But you know what? I'm kind of getting ahead of myself here. Give me a quick moment to quickly check to make sure things are good on the Twitch side of things, and we'll go ahead and continue. So as you can, well, that is if you guys can see and hear me right now. I cannot see and hear, or I cannot see your comments at the current moment. So let me go ahead and log into Twitch and see who's all here. But yes, Pamela really wanted to be here for the stream, but she isn't able to because of the IAU meeting. It's currently in the process of closing, but the closing ceremony is taking a little bit longer than expected. All right, let's see what we got here. Okay, I see that I'm live. However, I cannot see your comments just yet, and I apologize. Let's see. Oh, that's weird. For a moment there, it just flashed that CosmoQuest X was offline, but now it's showing that I'm live. What's up, Larry? Yes, I would have loved to actually have had some sort of like astronomy news update, but unfortunately, at the moment, I don't have one. And so I'm just going to try to do the next best thing, which is talk about my research. All right. Let's see who's all here, though. Hello, Adam. Hello, Binary Blaze. Hello, Decaf Smurf. Hello, Ed Thompson. Hello, Graham HW. Graham HW. Hello, Lance. Hello, Larry again. Hello, Magnus. Hello, Michael. Hello, RP Schwartz. Hello, Skinny Seahorse. Hello, Tom Van Scotter. And hello, Uncle Bill Drew. And welcome, guys. Honestly, that's probably the scariest part of these streams for me. Because I don't want to get anyone's name wrong. And there are a lot of good, like really good screen names here. And hello, Guido. I didn't see your name in the users list. Maybe it has to still update. All right. So back to business, guys. All right. So we're going to be trying to attach some coordinates to these images. Now, I was able to get further on along in attaching the latitude and longitude coordinates to some of the images. So what you're seeing here is not really an updated it's not really showing my progress. I'm kind of farther along, so I'm just going to change this up, and we're going to start with a different image, of course. All right, so let's do that. Now, much of what I'm doing you're not going to be able to see. However, I will try my best to describe exactly what I'm doing in the background. So at the moment, I'm just clearing the current images I had loaded up in JMars. JMars, for some of the viewers that weren't able to make it yesterday during my Astro 101 stream, JMars is a software package, which I'm not going to murder its name. So I'm just going to quickly look up what the acronym stands for here, because I always forget it. Right, JMAR stands for Java Mission Planning and Analysis for Remote Sensing Software Package. And basically, what you can do with JMARS, or at least what I'm currently using JMARS for, is taking a regular image that images a portion, in this case, of the lunar surface, and I'm assigning the latitude and longitude coordinates, that is the lunar latitude and longitude coordinates, to the images I have. And the purpose of doing this is to be able to determine how the images relate to each other spatially on the lunar surface. As explained yesterday, there's other software packages that does what JMARS does, specifically the ArcGIS package, software package, but it costs a ton of money, and right, we're not going to pay, or at the current moment, we don't need it that bad to pay the money that's being requested. All right. Right. And I apologize for that, for the stream title. Yeah, I'm pretty sure it does say daily space, right? Yeah. My apologies, guys. All right, so what we're going to do is load up a different image. At the current moment, you're seeing one of the LRO stamps, LRO or LROC stamps. So LROC stands for the Lunar Reconnaissance Orbiter Camera stamp. And basically, what's going on here, so let's zoom out. Come on, zoom out, JMars. It typically takes a little bit of time for it to load. The yellow box means that it's currently trying to load information up. There we go. So basically what's happening is within the background of the image, and I've set the transparency such that you can't see the background image. In the background, we actually have the lunar surface. So if I kept zooming all the way out, you'd see the lunar surface. And currently, I have one of the LROC stamps superimposed on that background surface. So if I remove the background, you can see the image. And all this information that's currently being shown within the JMARS application is actual data that has been taken by cameras that have imaged the lunar surface. So what I'm going to do is I'm going to get rid of this current LROC stamp that's currently up here. Or not get rid of it, replace it actually with a different stamp, and probably in a different location. So let me go ahead and pull up the set of images I have, and you guys can't see this right now, but I have about 26 images of the surface of the moon. Let's see. All of these images have been taken by the Lunar Reconnaissance Orbiter's NAC camera system, where NAC is an acronym for Narrow Angle Camera. The Narrow Angle Camera system is composed of two cameras. Both cameras taking images simultaneously of a field of the surface, where one camera would be designated as the left camera and the other camera is designated as the right camera of the Narrow Angle Camera system. All right. So where was I? Yeah, I'm much farther along. You know what? We're gonna have fun, and we're gonna go to a completely different region of the surface of the moon. Let's see if this is a different region of the surface. I think this image is... Sure, this image I think will work. And again, I can just look at the estimates I have. And again, some of the things I'm doing right now, you guys can't see, unfortunately. I would try to share my screen with you guys, but whenever I do that, there's a situation of where we have, like, if you put two mirrors together, you can kind of see an infinite number of mirrors on the screen. I don't want that to happen during the stream. So I'm just going to try my best to really explain what's going on here. I think no, this is not a different area. So, about half of the images I have, about half of the images that we use, and specifically these images are being used for CosmoQuest's Moon Mappers project. About half of the images are images of a region that's contained within the Apollo 15 landing region. Let's see. I think that this is outside. Okay, yeah, this is completely outside. So we'll go ahead and use this one. So the current image I'm going to bring up here is been designated as M161000252RE. And so I'm going to go ahead and bring it up. Now to do this, did I copy that image name? Let's go ahead and copy this first. Excuse me. My nose is kind of clogged right now. I hope I'm not coming down with the cold. That would really suck. So I've copied the name, and what I'm going to do is I'm going to upload this stamp. To do so, all I would need to do is open up the LROC stamps options. Let's see if you can see that. And you cannot see that. That it doesn't show actually, but that's okay. You will see the end result though. So I'm going to paste that. And let's see if I can get a way for you guys to see what's going on here. Let's remove this current stamp. Oops. Okay, I zoomed out a little bit more. Sorry about that, guys. Let's zoom back in. I'm going to go ahead and remove this current stamp. And to do that, you guys can't see it, but there's an option to delete rendered stamps, and that's what's happened with this current stamp. I've rendered it, so I can delete it, and it should go away. So now it's disappeared, and I'm going to go ahead and run a search for another LROC stamp that's in a completely different location. So to better be able to determine where the stamp appears, it actually requires for me to zoom out. So I'm going to go ahead and set the zoom level to a value of 2. And now you're kind of seeing a more global image of the lunar surface, where this image primarily shows regions of the lunar surface between the latitudes of roughly, it looks about 60 degrees north, which I'm assuming to be about negative 60 degrees south. I mean, negative 60 degrees north, or 60 degrees south. So in this particular view mode, I can see stamps that will be loaded, of course, if I remove the background image. All right, so I'm going to go ahead and do my search. At the current moment, no stamps are loaded. I'll update the search. It will retrieve the stamps from the server, which is what it's currently doing right now. Just have to wait a little bit of a while for that to happen. And okay, it's found the stamp. Now it's my job right now to find where the stamp is located within the map. I can get rid of this. So it's kind of hard to see it right now, but if I remove the latitude and longitude grid, I might be able to find it. And I found it. So the key thing is that you want to look for features in your map that are there once you remove the latitude and longitude grid. And I can see it, this like about the lower left hand corner of the view screen, there's a little like blue, it looks like a blue line at this scale level. But if I zoom in on it, you'll begin to see that it's actually it's the stamp that I requested. So we zoom in. There we go. It's coming into view. And right now, all you see is a blue rectangular box, or not box, but just a blue rectangle. So in order for me to actually see the actual stamp, and again, these stamps are superimposed on the background. And I don't know if you can notice, but this is a completely different region of the lunar surface. So I'll leave this at like about 50% transparency for the background. And I'm going to go ahead and load up or render this LROC stamp. And as stated yesterday, the cool thing about JMars is that you're also able to see several other planetary bodies. The surfaces of several other planetary bodies. Let's see. At the current moment, I have JMars set to view the moon. But you can look at the dwarf planet series. You can look at Earth. You can look at a few other planets like Mars, Mercury, and Venus. You can look at the now dwarf planet Pluto and some other astronomical objects within our solar system. All right, so I've uploaded this stamp. And the key thing, the reason why JMars is so useful is that all these stamps already have the latitude and longitude information embedded within the software. In this case, I can see what latitude and longitude I'm looking at just by looking at the lower left-hand corner of the JMars application. So my cursor hovers over a point, and at the lower left-hand corner of the JMars app, it'll show what latitude or what longitude and latitude I'm looking at wherever my cursor is currently at within the view window. All right, so I have that. My next step is to now actually upload the image I have that should correspond roughly to this particular, somewhere within the stamp itself. So I talk and I talk and I talk, and I need to look at some comments. Let's see if you guys have said anything. What's up, Astro, Junic, and Hiptacular, or Hello Raptor. I'm just gonna go with the last part of that. And hi, Susie. So yeah, we're gonna switch this up. We're gonna Astro 101 is doing a takeover for today. But from my understanding, whenever these stamps are being rendered, they're not being projected, so it's unprojected. So, but with the images I have though, all of the images that CosmoQuest uses for the Moon Mappers project have a projection. They've been projected into a Mercator projection, which requires for me to remove that projection to be able to actually view them correctly within the JMars app. And you'll see in a second what I mean by that. So let's go ahead and let's load the image I want to load up. And again, this image should be superimposed on the stamp that we're seeing right here in the middle of the screen. So let me remind myself again. Sometimes my short-term memory is not the best. So M161000252, and it's the right camera. All right, so I do have that. So you probably can't see what I'm doing right now. But what I'm going to do, and I think you can see my cursor. Hopefully you can. What I'm going to do is I'm going to click. So in the around the upper left-hand corner of our application here, we have this tab that states Add New Layer. So I'm going to click Add New Layer. Let me see if it pops up for you, and it doesn't. Maybe there's a way I can fix that. At the very least, you'll be able to see the end result of what I'm doing. So we're going to go ahead and we're going to add a new layer. And the layer that we're adding is going to be I'm uploading a custom map. So you know what? I really want you guys to be able to see what I'm doing here. So let's fix that. So we're going to put this as layer window, or add new layer, and press OK. Let's see if I can see where it's at. There it is. And so you should be able to now kind of see it. I'm going to shrink that. There we go. All right. So I'm going to add a new layer, and what this allows me to do is, in particular, upload a custom map. And so with the custom map, I have to identify the image I want to upload. File or URL. In this case, I have the file is all the files are currently on my laptop that I'm working from here. And desktop, master. And to make sure I don't really clutter up my computer, I typically store everything on my external drive, which is somewhere around here. But it's not with me right now because I have everything I need currently up on my laptop. And so the one that we're working with, M161, and it's the R. So it's going to be this one, M161RE at the end there. And so it's a JPEG. Now, as a JPEG image, it's strictly a JPEG. It doesn't have any sort of georeferencing information. And what I mean by that is that the pixel coordinates within the image does not have a corresponding coordinate in like a more physical system. What I want to do, though, is I want to add coordinates to the image, specifically to the header. And so I'm using another program to do this. The name of that program is GDAL. So let's go ahead and upload the image. And in this case, I actually have to enter the geospatial data for the image. And because it's not a global image or an image of the entire surface of the moon, and it's only within a particular region of the moon, I'm going to put regional image. And I have to specify what the bounding box is for this image. Now, in truth, the image that I'm going to be uploading does not image a rectangular region of the surface of the moon. It is quadrilateral in shape, but the coordinates don't make a rectangle. It makes some other sort of quadrilateral. It's not rectangular or square or any sort of parallelogram. All right, so let's bring that back up. You guys can't see this screen. You know what? Let's load this screen up too, so you can see what I'm talking about here. Oh, really? I didn't even notice that. So I have to keep loading up screens so you can see the screens. Sorry, I had to stop for a moment here. Well, I have to stop, but I'm looking at an image, a statement, or not a statement, but a message I'm getting on Slack. Andreas is always so helpful. He's sending me information that's going to be related to the paper that we're currently writing. A paper that's exactly associated with the research I'm showing you right now. So, let's see. You guys can't see this screen. What is up with JMars? Why doesn't it just allow... Not JMars, but with OBS. I wish it could just know what I want to be seen and it just shows it for me. That would be great. Okay, I feel like it's one of those moments where I can like look at comments because I'm not looking. All right, so I'm going to go ahead and allow this one to be seen as well. Map. Let's just name this as map. And so for those of you who are looking to use JMars, this is actually probably a little, a quick tutorial on some of the features that are available. All right, let's go ahead and do that there. Let's put that there. All right, so I've already told JMars what file I want to upload. Now I have to define the coordinates of the map I want to upload. Those coordinates are on my computer, and again, you can't see them because OBS is just like, it can't read my mind. I wish it could though, to some extent. So let's see. These are coordinates that I estimated a while ago. But the estimate that I took of the coordinates is not really the best type of estimate I can do. What I'm doing right now is really the best way of doing it. So let's just put estimate. And we're going to go ahead and upload this up, or load this up so you can see it. Where is it? Where is it? Text edit. There we go. And I'm going to shrink. I'm going to try to shrink that. And so really this is just a text file. Alright. So now that I have that, and I'm really cluttering up my screen here, I'm going to go ahead and upload the essentially the bounding box of this image. Now, if you look closely, if you're able to really see the values in this text file, I've defined the latitude and longitude of each corner. The only issue is this though. The images that we use for the Moon Mapper database have all been rotated in such a way that the shadow that's being cast by the sun onto the lunar surface, or no, not onto the lunar surface, but the shadows that you get by features on the lunar surface will be such that they will always appear on the same side. And the reason why that is done is so that users that are, or citizen scientists that are marking the craters, their marks aren't being affected by the fact that with one image, the sun appears to be on the left hand side of a crater, and on another image, the sun would appear to be on the right hand side of the crater. It's so that we can remove that particular issue with being able to identify craters. Now, in reality, though, these images, because they've been rotated, I have to be able to account for that when I'm doing what I'm doing right now. So, the northernmost latitude, let's see, I have to find that quickly. And so these are negative numbers. This always trips me up at times, even though I know a more negative number would be the southernmost point. But if you increase something in magnitude, it's almost like you're thinking like, oh wait, maybe that's the most northernmost point, but not the case. So in this situation, 50.85. Okay. So the negative 50.85 is going to be the most is the northernmost point. So this right there. And what I can do is I can go ahead and put that into JMars. And so now what I need to do is look for the southernmost point, which in this situation is a negative 53.05010. Go ahead and do that. Keeping everything as longitude degrees in units of degrees east, I need to find the westernmost longitude and the easternmost longitude. And all this information is given within my file. Now, for this particular image, I think I can feel confident in saying that these coordinates are not the best for this image, but they give a pretty close. It should give a pretty close estimate though of the coordinates for the corners. Let's see. So the westernmost longitude is going to be the one that's smallest in value. Negative 60. And I think that that's the one, right? So negative 60.1287. Let's go ahead and put that in. And negative 59.95. Right. So at times, research can be tedious, but it's so rewarding when things work outright. So I'm gonna go ahead and upload this now, and so it's working to upload it. Let's make sure. Let's see what you guys are seeing. All right, so this is a perfect moment again to just take a quick moment to look at comments. So yeah, J Mars, do any of you guys have any experience like using software like this? I think in general this is a GIS software where, if I'm remembering correctly, GIS stands for georeferencing imaging software. The other big name out there for a GIS software is ArcGIS, and I would use that. As many scientists do use that software for being able to do georeferencing stuff, but it costs so much money, so much money. All right, let's see what's going on with that image. If it's uploaded, actually, it's not uploaded yet. Okay, so actually I was reading on QGIS, um, and again, guys, like I don't have a lot of experience with the GIS software. Well, I'm sorry, let me not say that. I don't have a lot of experience using, for example, the GDAL software that I've downloaded onto my laptop. But when I was in the process of downloading GDAL, I did run across QGIS, and it seems like you can download that along with GDAL and do some stuff with it. But I haven't been able to look at Europa. I'm definitely gonna explore some of the other planetary bodies that are offered in J Mars. All right, what's going on? Let's see if it's loaded. Nope, it's still working. It has not loaded. It is taking a long time to do this. I guess I'm gonna have to just be a little bit patient here. Let's see. Oh, the Galileo mission is what has images of Europa. Let's see. This is taking way longer than expected. I figured that this would just be like done quickly. Maybe it's taking a while because of the fact that I just have a lot more apps open, or specifically I have OBS open. Let's see. But yeah, you guys, I know that a lot of you guys do some astronomy research. 1 minute. Hold on. What's going on here? Okay. Hmm. All right, that's completely unrelated. Something popped up on my screen just now, which is completely unrelated to J Mars. All right, I think it's working. That screen disappeared. Oh wow. Okay. I was not aware. I should have looked at the actual image itself. So it would seem that for this particular image in our database, it's a full LRO image. So let's go ahead and zoom in, which probably means I don't need to do much to it. remove. No, I have to do. All right, so what I'm doing right now, and I'm going to go ahead and remove everything, so you could just simply see the background. So what I'm currently showing is the background image we have of the moon. And this image is at much lower resolution. The stamp that I rendered earlier is an image that's at much higher resolution. Now, what I've uploaded now is the image we have in our database, and I'm now going to bring that into view. So you can hopefully you can kind of see the differences here. And so what I'm looking at here, it looks like there is a little bit of a shift. So I'm going to zoom in on one of the features. Let's see. There is a little bit of a shift between the LRO stamp and the image that I currently have, that I've defined the corner points for. Not an extreme shift, but a shift nevertheless. Alright, so this requires that I correct the corner coordinates. Alright, let's see. Well, let's look at this one corner, actually. Alright, so the upper left-hand corner looks like it needs to be decreased in latitude. And also its longitude needs to move over towards the left. Or more west. Alright. And so I can easily do that. And now so what I'm going to do is I'm going to actually use the GDAL software that I have on my computer to do this. Alright, so let's do this. So does OBS already currently have that uploaded? Or do I have that as an option? I think I do. Terminal's there. Let's see OBS. Let's see what you got. There we go. And I'm going to get rid of some of this other stuff that I have. So terminals at the top. I'm going to go ahead and remove estimates completely. Or just move it out of the way. Map, add new layer. Let's go ahead and remove that. And what's the last one I have there? Map. I think that's this one. Yeah. All right. So at the moment, you guys will only be able to just see the terminal and the JMRS application in the background. Yeah, I really, at some point in time, I really want to kind of get like a desktop that can handle these streams a little bit better. All right. So I already have the GDAL software up, but I need to make a few other changes. So I haven't been able to really explore all the functions that come available with GDAL. As of right now, my focus has primarily been on two of the functions. One of those functions being the GDAL translate function, which I've been using to be able to define the coordinates of the corners. And the way in which I do the definitions of the corners is by using an option called GCP, which stands for ground control point. So in this situation, I need to, of course, change the file names So let's just do that really quickly. So this is which one is this one? M161 and it's R. So M16252R. M16152R. And I want to now, and primarily what this function is going to do is it's going to allow me to read, well, it's going to allow me to state how I want the corner coordinates to be redefined. And it's going to make a TIFF file that information is in the TIFF header. So .tiff. But I also need to change the physical values that I'm using for the coordinates. And so I'll bring that back up so you can see what I'm talking about here. Estimates, that's the one. There we go. I'm going to just move this right here, just temporarily. And so I'm going to use these values. Let's see. I know when I first started doing these streams, like I would be talking and I'd be looking at like a particular window. Of course, I can see the window, and I'd be talking about what I'm currently doing within the window, but no one in the audience can see what I'm doing within the window. And it's just like, we hear you talking, and you're saying stuff, but we don't understand what that stuff is associated with. And so I try my best to like keep up with being able to show what I'm doing while I'm working. All right, so the 0, 0, the upper left-hand corner of the image that's currently uploaded into JMars. Let's see. And let me make sure that actually makes sense. Lower right latitude, -50. That's actually south. That's more southern coordinate. So it must be that this one actually has the correct orientation. All right. So this is going to be -50. Yeah, that's right. This is going to be -50.8501. Space -60.12870. For my next ground control point, I also need to make sure that I'm specifying the pixel coordinates correctly for the corner coordinates. Otherwise otherwise things won't go right. So let's see. I need to look at the pixel dimensions for this image. So let's find that 161R. And within my set of images that I have, the pixel coordinates are 2014 by 37,566 pixels. Okay. All right. So let's use that. Oops. Nope. That's right. There we go. So that's going to be the upper right-hand corner, and I need to define that as -50.85, and some more numbers, degrees latitude. Oh wait, I'm messing this up. That first coordinate is not defined properly. I need to change that. So the order is important when defining these ground control points. For the pixel coordinates, it's always XY. But for this first control point, ground control point, I've defined XY, right? They're the exact same value, but I mixed around the latitude and longitude. It should be longitude, latitude. It should be the correct order. So let's go ahead and just copy this. Let's erase it. Copy and paste. Make that correction. All right, that's that. This needs to be negative 59.95. I really wish that I could automate this process, but I haven't been smart enough to be able to do it, so I have to do it like this. Okay. Let's see. I need to redefine the X and Y for this one as well. So X is that. Y is this. And I'm going to take a quick moment to make sure I'm looking at. Streaming is hard. Actually, I mean, and I've told you guys this before. I enjoy these streams. The reason why is because if I'm not explaining something properly, I'm pretty sure someone's going to be like, that doesn't make sense to me. Or if I say something wrong, someone's going to be like, Matt, that's not right. And so it's always a good way to be able to practice, being able to explain things to others in a way that can be understood. And plus, I just love our conversations. As some of you already know, like in past streams, you'll bring up a topic that's completely unrelated to what I'm talking about, but they're like great tangents. And as many of you already know, like I'm really easily distracted by really good tangent conversations. See, for example, Guido's brought up a very good topic. So, like prior to the stream, Pamela was messaging myself and some and fellow CosmoQuest staff, and she was saying like they're currently they're doing the closing ceremony, but it's taking a long time, so I'm not going to be able to stream. And at the current moment, Andreas is not available. So she's asking the rest of the CosmoQuest team that streams, who can like cover the stream. And what really kind of like caught me off guard is that I guess during the closing ceremonies for the conference, they're dancing, and I've never experienced of dancing at a conference, and maybe it's because of where the conference is taking place. But it was very interesting. Assuming that she really meant they're actually dancing, and that would kind of, yeah. All right. Okay, so that's good. That coordinate pixel coordinate is good. So now I need to give the corresponding I guess the proper word would be and I hate killing this word. Let's see, selenographic, if that's how it's pronounced. If that's how it's pronounced, selenographic coordinates are basically just the latitude and longitude coordinate system for the moon. Let's see. 2000. This is the lower right hand corner. So I need to specify this and this. I realized that I probably went way longer than a typical daily space stream. So I'm probably going to end the stream like around 2 o'clock. And guys, thank you so much for hanging around with me while doing work. Because honestly, I mean, I love what I do. I love what I do. But Like I said before, it can get tedious at times. Thank you, Susie. See comments like that is what keeps me going. Keeps me going. It gives me energy. Let's see. Right. I was in the process of correcting this coordinate. I am so the way in which I've input the information is such that the coordinate should be input in a clockwise motion. I started with the upper left hand corner and I should be ending with the lower left hand corner. So, lower left hand corner means that x is going to be 0 and that y is going to be that, what is that? 37,566 pixels. Okay, that's what I'm looking for. Lastly, I can go ahead and give the corresponding selenographic coordinates. So that goes there, or goes there, and this one goes here. All right, that should be it. So I press enter, and again, I'm going to have to modify these coordinates as I move forward. But I press enter. It's going to take some time, right? And it's more than likely taking a much longer time to process the file because of the fact that the file is much bigger. Let's see. Let's look at some comments here. And it's done. All right. So that's the first part. So if I do a GDAL info, this is another command within the GDAL software package, and it basically just allows me to look at the header information of a particular image file. So if I do GDAL info for this TIFF file I just created, it'll show that I've defined the new corner coordinates there. The next step is actually to project the image such that, well, in this situation, I'm going to be projecting to an equirectangular projection system. And basically what's going to end up happening is I'm going to have vertical, the columns within the image should now all be constant in longitude, and the rows within the image should be constant in latitude. But I mean, this would automatically be expected because the coordinates that I've defined for the image and selenographic coordinates makes a rectangle anyway, so it should already be constant. So, but I'm going to be modifying that though in a second. So let's go ahead and use a different command, GDAL warp, which actually does the projection for me. Now, in my stream yesterday, someone did bring up the fact that I'm using EPSG 4326, which is a reference frame for Earth with this software. And I know that I should be working with the reference frame in terms of like the moon, but for some good reason, just using this coordinate system as the source coordinate system works for this projection for some good reason. I don't fully know the reason why at the moment, and I'm still trying to figure it out, but it works. So it's the reason why I'm using it. I've tried using other source coordinate systems, but it just wasn't working out correctly. Let's see. I need to bring that image up. M161 R TIFF. And so basically what I'm going to do now is I'm going to go ahead and apply the projection. And I'm going to create this new file called temp.tiff. Let's make sure though, because if the file currently exists in the directory in which I'm creating this new file, it won't overwrite the old file. So I need to make sure that the old file is gone. So let's go ahead and move that to the garbage. Go to the trash can. I should be good there. I'll go ahead and do this. And it's working. And so once I've created this temp.tiff file, I'm going to go ahead and upload the file to JMars. And I'm expecting it to look exactly like its corresponding did I say that correctly? I'm going to upload the TIFF file to JMars, and I'm expecting for the TIFF file to look exactly like the JPEG file. Basically meaning that there should actually not be any sort of like real projection occurring. But once I start making changes to the corner coordinates of the TIFF file, then you should start seeing the slight changes. Or better yet, you probably won't see the slight changes because I'm seeing it's now almost close to 2 o'clock. So I'm going to probably end the stream soon. But honestly, I've been spending a lot more of my time lately doing writing the paper. Specifically, writing up the methods section of the paper, because much of the methods have already been done, or the procedure that I've implemented for the analysis. Much of that's already been done, so I'm currently just writing that up. All right, so that's done. So now I can go ahead and go back to JMars now. So let's go to OBS. Let's move some of this stuff around. I can get rid of this as well. All right, there we go. And we're going to upload it, and you'll see that it looks exactly the same. So let's see. JMars, where are you? There. So we're going to go back to adding a new layer. And this is no different than what I've done before. No, let's just go here. Where is that? JMars map. This is the one I want to show. All right. So JMars, add new layer, upload custom map. There we go. You can see it. And so I'm going to go ahead and do a quick browse. I'm going to navigate back to this directory, and I'm going to upload the temp file. In this situation, I don't have to define the geospatial data coordinates within JMars, because it's already offered within the header of the file. So I'll click contain within image, and I'll upload. And so the map already exists because I've been working on other images. I'm just going to overwrite that map, and it's going to work for a little bit of time, and eventually give me the file that I want uploaded into JMars. Well, it's not 2 o'clock, guys, and I really enjoyed being able to kind of like hijack daily space today. Oh, definitely. Yeah, I realize that being able to access papers through actual journals can be difficult. And so I'm actually happy that Astro PH is around. So we'll definitely be sticking this paper on Astro PH. Or, well, not Astro PH, but whatever the corresponding subject is for that's associated with. That's a good question. Look at that. Thanks, Guido. so that's what it was. Austrian folk dances. Okay, okay. So that, yeah, it makes sense. That's what she was talking about. All right, guys. Well, thanks for hanging out with me and having a great conversation. So Daily Space, though, of course, will be back tomorrow. I believe around 12 o'clock p.m. Central Time, or no, that's not right. I think it's gonna have the same time tomorrow, which would be 1 o'clock p.m. Central Time. Is that correct, Susie? Do you know? Or Guido? That's I believe it, but actually, or we'll be streaming at 12:15 p.m. Central Time. And so I look forward to seeing you guys then. Okay, so yes. So Guido and Susie are both saying that we're using a modified schedule this week and time zone. So Space will be airing or streaming tomorrow at 1 p.m. Central Time, 2 p.m. Um, Eastern. So, all right, guys. I will see you guys tomorrow. All right. Okay. Bye.